Okay, good morning everyone. Welcome again and thanks for joining us today. Today we are going to show you how we can code everything, including our infrastructure, pipeline, application. So today's presentation will be about running our workflows on AWS, and we are going to make a live demo with Onur today. So my name is Onur Salk. You can call me OS. I am one of the AWS community heroes in London. I am also managing partner, AWS managing partner of Kloya, and my friend also is Onur. He is also working with us. He is also a managing partner in Kloya. We've been using AWS several years, and what we are doing is we use AWS, of course, mainly our cloud provider. Also, we love to use kubernetes and Terraform, as you know. So we are one of the advanced consulting partner in UK, and we are based in UK, which we have 20 plus consultants. So our main focus is DevOps and Microsoft workloads. So why we need everything as code? I think we already know this, right? Because I think in this room, many of us already using many configuration management tools or provisioning tools. So what we have when we do everything as code, we have consistency, and we have a repeatable code. That, for example, you have a project that you start to prototype it on a dev environment, and then you are sure that it's ready to go to production. With just one click, when apply, you are able to provision your same stack into a production environment. Or you are already running in one of the AWS regions, and the business decided to move to another region. So it's easy for us, right? So we can also integrate our code into pipelines. So again, it can be a infrastructure code, it can be a Kubernetes deployment files, whatever it is. And so we are controlling and managing it with source via source control. That means everyone in the team can have an idea of what's going on in our environment, and also can make can give a feedback about you that, for example, this is wrong. For example, we need that compliance, and then you are doing wrong. This security port, rules should be more hardened, for example. So today's demo will be, as you can see here, we are going to deploy a stack on top of AWS using Terraform. And at the end of the day, we are going to have a pipeline, and we are going to have a Docker registry, and we are going to have a Kubernetes cluster. So as soon as we provision the environment, the pipeline will fetch the application code from GitHub and then deploy it to cluster, hopefully. So yes, this is the AWS infrastructure. So we have an EKS. I don't know if you are using EKS already. Can I see your hands? Anyone using EKS? Okay. So we are going to have a pipeline stack which will have code pipeline and code build, and which will push the Docker image to ECR. We will have a S3 bucket for keeping our Terraform state, and also we are going to have Route 53 to keep our records. Okay, so we have limited time. I think we have to start with live demo. So I'm giving word to Onur.
Thank you very much. As Onur mentioned, today we are going to use Terraform to do a demo. As first step, I want to start applying, because it will take some time, roughly 10 or 15 minutes. Then I will explain you in detail what I'm going to do. I'm just applying now. I will go into detail later. Let me see, because of the internet connection. Okay, a bit slow, but it will work hopefully. Perfect. Okay. First of all, today we are going to install an application. It's a famous Docker voting app, if anyone heard about it. One of the good Docker examples. We chose this example because it has many components in it, 5 different components, including Python, Node.js, .NET, Redis, and PostgreSQL database. So it's a good mixture. It will show us a different variety of technologies that we can use in the same pipeline. And this is our pipeline a bit in detail. As you can see, it consists of 3 stages: sourcing, building, and deploying. We are going to use GitHub provider to pull the image, connect from GitHub. And then it pulls the source code, and it will put everything to an S3 bucket, an encrypted S3 bucket. So second stage, build stage, will grab all the artifacts from S3 bucket, and it will execute our build spec YAML file. This is so similar to the Jenkins file. It just contains our codes, and it will execute them one by one. In a nutshell, it will create Docker images, it will build the images, and push it to ECR. And the last stage, again, we will use a code build project, which will update our EKS cluster and update our application. The only problem here, you may think that why don't we use code deploy, and we are using code build. Unfortunately, at the moment, code deploy doesn't support EKS yet. It will be there, but for now, we are using code build. Let me check if everything goes fine. It looks that it's great. The creating of the EKS cluster will take roughly 10 minutes. Because of that, at that time, let me show you our Terraform script so we can quickly talk about it. This is the Terraform directory, and as you know, Terraform just goes through.
Sorry, could you enlarge it? Because you can't.
Sure, right. Is it better? Cool. So Terraform will go through all the TF files here and execute one by one. As you can see, we create our AWS provider. That means we will do all our operations on an AWS account. This is our main TF file, which includes 4 modules. VPC, we created different modules to distribute all the code, separate the code logic. We create all the network components in this module. We create all EKS related stuff in this module, and code build projects and code pipeline. And here we separated the Terraform configuration. We have created the S3 backend and encrypted because of we don't want to lose, let's say, TF state files. Otherwise, they will be stored in the local. And when I push my code onto GitHub repository, and a colleague of mine can pull the code, but when they want to execute, Terraform will not know what happened before. To avoid that confusion, we store all the TF state files in an encrypted S3 bucket, so it uses this as a backend. And as you can see, we have modules files here. All the modules you can see on here are here. For instance, we can go VPC and check what are we doing here. As an example, we create VPC, subnets, private and public subnets, Internet gateway, Elastic IP, NAT gateway, route tables, and security groups, all the related network stuff. So actually, we call this everything as code, so that includes infrastructure as well. Creating the network, if you need, you can create site-to-site VPN tunnel, whatever you need. After the VPC has been created, we use EKS. As you know, security is one of the best features and most important features of AWS. Because of that, everything is managed by roles and policies. Because of that, for the role-based access, we create some roles necessary. We create cluster. And when you create an EKS cluster on AWS, it creates a Kubernetes control plane, if you are familiar with. So you don't need to manage that. You don't need to use servers. You don't need to manage those servers. But we still need some workers. And we will use EC2 instances for worker nodes. To be able to do that, we create, again, rows, so that when we assign these rows to EC2 instances, they can go and attach themselves to the cluster. And we are going to use auto-scaling group for that. let me show you where it is. Okay, this is the bootstrap. You can see that we are executing etc EKS bootstrap sh, and we give the cluster name. Because we are using a special AMI, which is EKS worker node AML. You can find it on AWS website. When you start an instance, initiate an EC2 instance with this, you need to run the user data with the cluster name so that they can go and attach themselves to the cluster. Because of that, using Terraform, we create the launch configuration and an auto-scaling group. By the way, let's see how is it going. Good, probably it will take 5 more minutes. And also, if you realize here, let me make it a bit bigger again if you can read. We also have a null resource for EKS endpoint. Terraform is waiting for a resource to be created completely. But the problem is, as you know, when you create a resource on AWS, it creates a DNS name also. Not user-friendly, but you can access publicly. But the problem is the resource is available, but the DNS resource hasn't been populated yet. So if you want to use it directly, we will have a problem. Because of that, we have created a shell script to check if the endpoint is active. So it will take roughly 1 more minute after the resource creation completed. For instance, I can show you that script on scripts, under scripts folder, wait EKS. Very simple shell script that uses AWS CLI, goes, executes the describe cluster, which takes the endpoint, and after taking the endpoint, it just, to not get if it's active. I will share the source code. I will show you the links so you can access them from GitHub. You can just play around. If you have any questions, please don't hesitate to ask. We'll be more than happy to help you. I show those. As you can see, null resource, this is the config, because when the cluster is up and running, we need to update our kubeconfig file. So we do it here. We create the Kubernetes provider so that we can install Helm and then use Helm for Helm chart installations. When the EKS cluster up and running, including the worker nodes, we have pipeline. And pipeline modules, again, with roles and policies, always. After the policies, we create the pipeline. So in the pipeline, you can see the stages here. This is the source stage. You can see that we use third-party GitHub provider to connect our external GitHub account. And you can see the configuration here. Did you realize when I do the Terraform apply, I just sent an additional command line argument, which was the GitHub O token, because I didn't want to store any sensitive information in the code repository. Because of that, excuse me, we just set GitHub token over there. And you can see that we read it from variables there. So that means everything as code doesn't mean that you have to store any sensitive information on your code repository. Of course, the best scenario is to use a secret management tool like Vault or whatever you want to use. But for demo purposes, we don't want to spin up another server again. The second stage is the build stage. You can see that we use code build. And code build actually, the output artifacts means it uses S3 bucket and tags, let's say, the zip file with code build. So in another stage, you can pull with that tag, which you can see that in deploy, input artifacts is the output artifact of the previous one in the code build. And we create the webhook so we can go connect our GitHub account. Let's see how is this going. Oh. Let's see if it is updated here. We have our VPC created. Subnets created, public and private subnets, internet gateway, all looks good here. Not gateways. And let me go and check the EKS cluster. Actually, EKS cluster is active, it means up and running. That is also good. Let's see if we can create auto-scaling group. It looks good. That means we have an instance here. Good, and it's still an initializing step. Probably because of the internet connection, we had a problem. We need to wait this to be up and running at the moment, but we can hopefully check cluster information. It's B53OB. Let's double check this. If this is the correct cluster. Yes, this is our new cluster. So probably we don't have any nodes yet. Because we still wait for the EC2 instance to complete. By the way, let's see what happened here. Let's go again. It may give a timeout, exception. So when you apply Terraform again, it checks the state file and compare the active results and what it has, and it gives you a list of actions that it will do. And here we can see that the component which threw an exception was AWS auth, so it will create again, and those resources will be executed again. So let's give it another chance. This looks good. Now it's fine. And if we try to get nodes, we have node here up and running at the moment. You can see that the worker node has attached himself to the cluster. So that means our Kubernetes cluster is ready. If we go back here and check the code pipeline, this must be created also. You can see we have one pipeline and it's already in progress. The reason is when you create the pipeline, when it's up and running, it automatically goes and connects to the data source. So it will do the execution right away. If we go into detail, do you remember the pipeline detail here? We have 3 stages. You can see that source stage, build stage, and deploy stage here. And also we can go into check details. It just connected, and you can see it just reads your commit message as well. The build state was the code build. We can go and check what has happened there. If you click on the build run, you can see the details, the log files. Before showing you this, let me show you our build spec file. So this is the application code, and this is the build spec file, which actually the build stage, when it pulls the code, executed that file for us on a Docker environment, which you can see it just goes and logs into ECR because we store our Docker images in Amazon ECR. And you can see that it just goes and builds the application. Do you remember the applications here? We have a Python, Node.js, and a .NET application. So we went to source code and built all those applications, and then tag, and then push them to ECR. We can come here and double check. it goes and you see logged into ECR, does all the build here, and hopefully pushing at last. Yes, all the pushed and the status is success. If we go back to pipeline, we can see that it succeeded. That means deploy stage is also succeeded. We can see that on the logs, if we check, it went and applied all the Kubernetes manifest files, which we have inside the code repository. Okay, and one last thing before we go on, we used a component called external DNS. I can show you here with Helm. If you can read external DNS. As I just mentioned, AWS resources have some unfriendly long names, and we don't want to use it in production for sure. And we use a component called external DNS, which you just set an annotation to your service. And if your service is type of load balancer, of course, you need to give them some access rights with roles and policies. It goes and connects to Route 53 and creates an alias record for you. So we can also double check this one, Route 53, hosted zones. And we are going to use Cloya.net. Okay, as you can see, result.cloya.net and vote.cloya.net is created. And we are going to use those in here. For voting app, we'll use vote.cloya.net domain. And for the result, to see the result, result.cloya.net. Hopefully, we won't have a problem on DNSs, and let's see. The application is up and running at the moment. This is the famous Docker voting app. And if we go to vote.cloya.net, you can do this. So let's say if you say cats, we can see that it's up and running. So I want to send a vote from my phone so we can see the change in here. Oh, somebody also does it. Thank you very much. Okay, this is good. So now we executed just one line of Terraform script, and we create an infrastructure, and we create our pipeline, which executed the code. This is good, but this is not real life. We need one more thing, right? Your developers are just doing the development, perfect, but we need up and running all the time, 100% up and running application, and without downtime, we need to see a new version of the application. So let's do this now. This is one more step further. So I don't want to change everything now, and just I prepared it before. So if we go and let me make it bigger for you. So this is our application folder, and if we check that, you can see that we have some changes. If we check what is it, we have some changes. We did an update to our application. Let's add everything, and let's say V2, our new application. And we push to our GitHub repository. Sounds good. Now we expect our pipeline to grab everything without any need of us to do an click on build or touch anything. So if we go and check our pipeline, we should expect that it's working. It's in progress. This is good. This is promising, actually. And if we check, as you can see that now source stage has the V2 here, so our new commit message. And now build stage has been executed, and it has the same V2 commit message. The deploy is succeeded. It's the previous execution. It's still cats and dogs, as you can see. We can go to code build project again, and you can see the history over there. The previous execution was success and done on 7 minutes ago. Sometimes it might be confusing, and you can click, you can check. I think this is the best option here. You can see when it did. And at the moment, our new build is in progress. If we check, it creates the images at the moment. As you can see, it does all the Docker builds. And the idea is 0 downtime deployments here. And we did our change, we sent it to repository, and pipeline has started. So to be able to do that, we should check our application. And it's still up and running. When the execution completes, we should directly see the new version right away. That's the main idea of 0 deployments, 0 downtime deployments, I'm sorry. Of course. So if everyone can see, you can go browse and vote there. Also, while it builds, I can show you. Okay. As you can see, we create a different namespace to separate everything. I want to switch to that namespace now on Kubernetes, and if we do get pods, you can see that we have 5 components are running, which is database, Redis, result, vote, and worker. So all 3 applications and 2 databases are running at the moment for the last 8 minutes without any problems. As you can see, we don't have any restarts from Kubernetes. And if we check this, it looks that it's pushing at the moment, so it's so close to complete, which is succeeded, which means we have one last stage. Of course, if you want to do it more friendly, you can just send notifications to your Slack, to email, to the teams, or test teams, as you prefer. For demo purposes, we just build and check in manually. Okay, this is in progress. And if you go to phase details, you can see actually what is it doing at the moment. You can see that it take into a queue and then provision it. Means it creates a container for us so we can execute our build spec YAML. And it looks completed. This is promising. So now we should expect everything is updated. So I will go and refresh. And now our new application for Brexit. And please go and vote so we can see what's the result. And we are done. Thank you very much.